Okay. Hello everyone. I'm Lola Rosa and this is my project. Ano to? I'm here to discuss or to continue my lesson on data manipulation in SQL. And it seems that I'm stuck on this chapter, on this correlated queries, nested queries, and the common table expressions. So actually this is a topic wherein I can't seem to absorb. So I'm stuck in this topic, and for the past few episodes or the past few what do you call that? Past few streams, I've skipped this because, as I've said before, I'm stuck on this topic. I can't seem to absorb. So, but I have two. So let me proceed with the common table expressions. This is where I'm let me see if I can remember this.
Great job getting the hang of nested and correlated subqueries. As you probably noticed, the queries we have been setting up are quickly becoming long and complex. It can become difficult to clearly keep track of each piece of your query, why you need it, and whether or not it's necessary. In this lesson, we'll cover a common method for improving readability and accessibility of information in subqueries, the common table expression. Common table expressions, or CTEs, are a special type of subquery that are declared ahead of your main query, just like you see here. Instead of wrapping subqueries inside, say, the from statement, you name it using the with statement, and then reference it by name later on in the from statement as if it were any other table in your database. Let's rewrite a query from an exercise that you completed in Chapter 2 by using a CTE. The query you see here uses a subquery, S, in the from statement to generate a list of country IDs and match IDs that meet a certain criteria. Specifically, we only wanted matches with 10 or more goals scored in total. This subquery is then joined to the country table, and the number of matches in the subquery is counted in the main query. Here are the results of that query: a short list of countries with very few high-scoring matches. In order to rewrite this query using a common table expression to represent the subquery, simply take the subquery out of the from clause, place it at the beginning of your query, declare it using the syntax with, followed. In order to rewrite this query using a common table expression, instead of wrapping subqueries inside, CTEs are a special type of subquery that are declared ahead of your main query, just like you see here.
Usual for me to absorb, for me to be able to absorb the topic, I have to write it. I'm old school. I have to write it for me to be able to remember the format. As I've said before, with the actual practice of coding, we can always search for the proper syntax and then copy and paste. But since this GUI, this user interface from datacamp, doesn't allow us to paste. We can copy, but we cannot paste on its GUI. So I have to remember the syntax or the sequence of the syntaxes.
Instead of wrapping subqueries inside, say, the from statement, you name it using the with statement, and then reference it by name later on in the from statement as if it were any other table in your database. Let's rewrite a query from an exercise that you completed in Chapter 2 by using a CTE. The query you see here uses a subquery, S, in the from statement to generate a list of country IDs and match IDs that meet a certain criteria. Specifically, we only wanted matches with 10 or more goals scored in total. This subquery is then joined to the country table, and the number of matches in the subquery is counted in the main query. Here are the results of that query: a short list of countries with very few high-scoring matches. In order to rewrite this query using a common table expression to represent the subquery, simply take the subquery out of the from clause, place it at the beginning of your query, declare it using the syntax with, followed by a CTE name, and as. So here, we're starting our CTE S.
So the sequence of the code is different because as we've studied before, the usual syntax for querying begins with the select word, then followed by the column names, then from the table name or table names, and then again followed by where, then the condition on or the filter for the data to be extracted. So with common table expressions, we have to begin with the with clause with alias as, or with the variable as. So it says it that we have to place it at the beginning. So So it says here that it is a common method for improving readability and accessibility of information in subqueries. So, uh, wait. So common table expressions or CTEs are a special type of subquery that is declared ahead of our main query. So instead of wrapping subqueries inside, say from the where statement, you bring it using the with statement and then reference it by name later in the from statement as if it were any other table in your database. So, okay. So parang, okay. I think it's similar with the placing the result of the query into a variable. So, um, okay, the resulting query from the select country ID from match where home goal plus away goal is greater than or equal to 10, the resulting query will be placed on the variable S, I think. Okay. So, it's similar to select the column names from the table name where the condition, then into a data container. Okay, I think I have to visualize it as if I'm using an alternative query statement, but similar with the uh, similar with the similar that would give the same result. Similar result. Okay, so take a subquery in from. So let's rewrite the query from an exercise that we've completed in chapter 2 using a CTE. The query that we see here uses a subquery S in the from statement to generate a list of country IDs and match IDs that meet a certain criteria specifically. So we only wanted matches with 10 or more goals scored in total. The subquery is then joined to the country table, and the number of matches in the subquery is counted in the main query. Here are the results of that query, a short list of countries with very few high-scoring matches. So, actually, I'm just reading the transcript of the video, but it's because for me to be able to absorb the lesson, I have to read it again and again. Okay, so in order to rewrite this query using a common table expression to represent the subquery, simply take the subquery out of the from clause. Place it at the beginning of our query. Okay. Okay. Then declare it using the syntax with followed by a CTE name and as. So we will alias it at. Okay. Then starting with our CTE, which is in this case, the variable s by stating with s as, and then placing the subquery inside the inside parentheses. It's now a common table expression. Okay. So as I've said before, I think this CTE is similar to uh, selecting or generating a select query, then placing it into another data table. So in this case, you just have to place it at the beginning with as a with clause, using the with clause. So then complete the rest of the query the same way that we would if the CTE were an existing table in the database. So you select the country name from the country table, count the number of patches in the CTE S. The S here is the common table expression, so the CTE. Then join S to the country table, and then group the results by the country names alias. So the results are identical to the previous query setup. So we're just trying to this is just illustrating different ways of selecting a query, running a select query. So if we have multiple subqueries that we want to turn into a common table expression, we can simply list them one after another with a comma in between each CTE and no comma after the last one. With a comma in between each CTE and no comma after the last one. Okay, so so if we have 3 CTEs, we have to place a comma in between the 3, then no comma on the third. So a comma after the first, and then another comma after the second. Then after the third, we don't have to place a comma anymore. So then we can retrieve the information that we needed into the main query. Just make sure that we properly join this second CTE as well. So actually it's the same with selecting columns. When we select columns, we just place the commas in between the column names, and then we don't have to place another comma at the last column. So why use CTEs? So it says here that why are we learning yet another method of producing the same result in a SQL query? Common table expressions have numerous benefits over a subquery written inside our main query. First, the CTE is run only once, and then stored in memory. So it often leads to an improvement in the amount of time it takes to run your query. Okay. So it is faster. Gathering data is much faster. Then second, CTEs are an excellent tool for organizing long and complex CTEs. So we can declare as many CTEs as we need, one after another. We can also reference information in CTEs declared earlier. So for example, if we have 3 CTEs in a query, our third CTE can retrieve information from the first and second CTE. Then finally, a CTE can reference itself in a special kind of table. Called a recursive CTE. Then we'll briefly discuss some more advanced applications of CTEs in the next lesson. Okay. So, okay. Let's hear it again from our instructor.
By stating with S as, and then placing the subquery inside parentheses. It's now a common table expression. Finally, complete the rest of the query the same way you would if the CTE were an existing table in the database. You select the country name from the country table, count the number of matches in the CTE S, join S to the country table, and then group the results by the country name's alias. The results, you guessed it,
It's it's not that simple. It's overwhelming for me. uh-huh. So on the first query, we placed it on a CTE, and then okay. I think I'm getting I think I'm getting the what's this? Why is it stated here that online for 1 hour, wherein I'm only here for 30 minutes? Why? Hello, Sarah. Ay, thank you, Bastardo. Thank you. Thank you, Bastardo. Thank you so much.
are identical to the previous query setup. If you have multiple subqueries that you want to return into a common table expression, you can simply list them one after another with a comma in between each CTE and no comma after the last one. You can then retrieve the information you need into the main.
It's getting complicated. hope I can absorb this. With S, select query. Okay, with S as, then the first subquery followed by comma, then S2 as another subquery, S1 as, then S2 as, then the third select from it's very complicated. Thank you so much. I hope I can help you. So,
Main query. Just make sure you properly join the second CTE as well. So why are we learning yet another method of producing the same results in a SQL query? Common table expressions have numerous benefits over a subquery written inside your main query. First, the CTE is run only once and then stored in memory, so it often leads to an improvement in the amount of time it takes to run your query. Second, CTEs are an excellent tool for organizing long and complex queries. You can declare as many CTEs as you need, one after another. You can also reference information in the CTE declared earlier. For example, if you have 3 CTEs in a query, your third can retrieve information from the first and the second CTE. Finally, a CTE can reference itself in a special kind of table called a recursive CTE. We'll briefly discuss some more advanced applications of CTEs in the next lesson. For now, let's practice writing CTEs by modifying queries in exercises you completed in Chapter 2.
okay. So, first should be with us. I think I'm getting the, I'm slowly absorbing it. With match list as select country ID. So let's read first the instructions. So clean up with cities. In chapter 2, we generated the list of countries and the number of matches in each country with more than 10 total goals. The query in that exercise utilized a subquery in the from statement in order to filter and match in order to filter the matches before counting them in the main query. Below is the query that we've created. So here's the query. Select c.name as country, then count sub.id as matches from the table country as C. Inner join country ID from match where home goal plus away goal is greater than or equal to 10. A sub on C.id equals that country ID, group by country. Actually, country as matches from inner join country ID. Okay. So the inner join is the whole query on the inner join is what is aliased as sub. So the entire subquery select country ID from match where home goal plus away goal is greater than or greater than or equal to 10, the entire query there is the sub. Okay, on see the tide. Okay. So we can list one or more subqueries as common table expressions. So from the query on the left, on the right, we're going to code the equivalent query or the the yes, the equivalent or the similar query that will generate the same result, but this time using the common table expressions or the CTE. So we can list, wait. I thank you again. Thank you for the snacks. Start. Thank you. So says here that we can list one or more subqueries as CTEs by declaring them ahead of our main query, which is an excellent tool for organizing information and placing it in a logical order. So for in this exercise, we will have to rewrite a similar query using a CTE. So I've said before, we have to code a similar similar query from the left, but this time using the CTE. So for the instructions, complete the syntax to declare your CTE. So with match list as select country ID. Wait. Select the country ID and match ID from the match table in your CTE. Okay. Again, let's check on the structure. These tabs here, this tab here is the query result. When we run the code, this is where we gonna see if our code has a result or if it generates an error. Then these two tabs here are the tables or the data tables. So it says here that we have to select the country ID and the match ID from the match table in our CTE. So this is the match table, and the match table has a country ID column and also an ID column. So simply ID from match, where home goal plus away goal is greater than or equal to 10. Then select league and count of matches from the CTE. Then left join the CTE to the league table using country ID. Read, okay. Open, close, select. L name as league, count, match list ID as matches from. Join the CTE to the league. Left join the CTE to the league table using country ID. So league, league that ID the CTE here is match list. So left join on match list. It's match list. On L.ID. Left join the CTE to the league using country ID. Using country ID. League.id equals country ID. But it also has a country ID column. League using the country ID. 7 league ID, country ID. Wait. Thank you again. Thank you for the snacks. Bustardo. Left join to the league table. Left join match list on it's just the two of the match table has a country ID, and it says here that we have to left join the CTE, which is the match list, to the league table using country ID. But the league table here has its own country ID, but on the condition here they've used the league.id or L.id, and this is the L.id. Then how can I but the league ID, I think it's similar to the league ID here is, I think it's similar to the country ID. So match list, the match list that country ID. Okay. The ones um, who are making these these exercises is making it so confusing because both of the tables have the ID column and also the country ID column. So it really confuses me what to use as the key for the, but it was specified that we have to use the country ID, but on the league table it chooses the ID column. But upon inspecting the content or the rows on the league table, the ID column and the country ID column seems to be the same, have the same value. Okay. So organizing with CTEs. Previously, we have modified the query based on a statement we completed in chapter 2 using the common table expressions. So this time, let's expand on the exercise by looking at details about matches with very high scores using CTEs. Just like a subquery in from, we can join tables inside a CTE. So for the instructions, declare our CTE where we can create a list of all matches with the league name. Declare our CTE. So once again, with match list as, then the league date, home and away goals. From match. So from the CTE. So the CTE thank you again. Thank you for the snack, Mustardo. So as league match has home goal. much as M, but league here has no league. Select. From match M. Left join league as L. Then filter the main query for matches with 10 or more goals. Na naman ako. Okay. Select the league, date, home, and away goal. So, league from the CTE, and the CTE is the match list. Then antok na antok. Always inaantok. Then where total goals equals total goals, filter the main query for matches with 10 or more goals. Total goals is greater than or equal to right. Where total goals is greater than one goal. There was an error, so this is aliased as missing from clause entry for table L. Wait. League name as league. Can I just place your name? Sinubra na siya eh. So, bakit? Wala nga siya sa match eh. Nasa big siya eh. Then, date is inner join. On country ID. It's just 940. So, inner join. Ito palang error ba yan? So, ang error yung date sa date should be, uh, wait, let's see. Match. Okay. I thought my error was on the L that name as league, but it seems that the error is on the next, on the second column, the M that date. Because before I've only placed that date column there. Uh, One, two, three, four, five, six. Still a lot to go. Okay. So CTEs with nested subqueries. If we find ourselves listing multiple subqueries in the from clause with nested statement, our query will likely become long, complex, and difficult to read. So since many queries are written with the intention of being saved and rerun in the future, proper organization is key to a seamless workflow. So arranging subqueries as CTEs will save us time, space, and confusion in the long run. So for the instruction, it will save us time, space, and confusion. But it's giving me a lot of confusion. So declare a CTE that calculates the total goals from matches in the August of the 2013 and 2014 season. I have to check on. Let's see. Hello, hello, hello. Hello, how are you? I'm finding. Okay, so declare a CTE that calculates the total goals and from matches in August of the 2013 and 2014 season. So, okay. Read match list as, okay, select country ID, then home goal plus away goal as goals. Then from match, create a list of match IDs to filter data in the CTE. So where ID in, select the league name and average of goals in the CTE. Create a list of match IDs to filter data in the CTE. So filter data in the CTE. Let's join. I'm stuck again. ID in select. Syempre, if we have to use the where ID in selecting query from your season. Wait. Okay. So here much, because only the match table has the season. Match. Filter data in the city. It's 29, 20. It's 2013 and 2014 season. Then extract month from match list. Extract month from month from, so let me see, from date, because only the date column here has a we can only extract the month data from the date column here, so obviously it should be date. then equals season August. August. So I'm not sure if extracting data can can generate August or 8 month. So month from date August. Wait. From the match list using country ID. Wait. Ah, with country ID, home goal as goals from match, create a select ID where ID country ID. Akala ko tapos na. Meron pa pala. Okay. So, filter the first on the inner subquery to only select matches in August of the 2013 and 2014 season. But I cannot do that because it still have. Thank you so much. Thank you, Bastardo. Select the league name and average. Why is that instruction not complete? Select the league name and average number of goals. So, ABG. The goals. I think the goal from league as L. League. From the CTE. The CTE on the CTE as goals. So match list that goals. Thank you so much. Then left join the CTE onto the league table. Match list on the ID is equals to match list. Excuse me. Match list that country ID. Select the league name. The league name here is from league as L. So name. Because it is alias as L. But, but anyway, it's just
At this point in the course, you're probably wondering why we're covering so many different methods of performing similar tasks.
yes, I'm already.
That's a great
wondering.
question. The simplest answer is that yes, there's a lot of overlap between use cases for joins, subqueries, and common table expressions. Many questions that you can answer can use these techniques interchangeably without sacrificing query runtime or the accuracy of your output. But these techniques are not identical. Let's take a minute to compare the techniques we've been using in this and the previous chapter. Joins allow you to directly combine information from two or more tables, and on their own are mostly limited to simple combinations and aggregations of tables already present in your database. A correlated subquery allows you to combine information between a subquery and a table or another subquery. These help you simplify your syntax and circumvent the limits of a join, namely that you can't join two separate columns in one table to a single column in another at a time. We saw this in the match table, where you can't retrieve the team name from the team table for both the home and away teams at the same time. A correlated subquery can solve that problem. However, it's important to remember that correlated subqueries take a long time to process and will slow down your query performance. Multiple and nested subqueries are useful when your data requires multi-step transformations before it's in the form you need for your final query. Breaking down the steps of your query process allows for better accuracy and reproducibility in your work. Finally, common table expressions allow you to organize your subqueries sequentially by declaring them at the beginning of your query. Since CTEs are processed one at a time before your main query, you can reference information from a CTE created earlier, thus serving as an alternative to nested subqueries. So which one do you use? Often it really depends on the database you're using, the field that you're in, and the questions that you're asking. In general, I recommend that you practice each technique with your own databases to determine which one allows you to best use and reuse your queries and generate clear and accurate results. Before we move on, I'll share a few examples of questions that each of these approaches can be used for. As you've seen, joins are a universally important skill when working with a database that has more than one table. It's fair to say that joins are necessary to understand each of the following techniques. Correlated subqueries are great for matching data from different columns in one or more tables, such as determining who each employee's immediate supervisor is. Multiple and nested subqueries are great for answering questions such as, what is the average deal size closed by each sales representative in the last quarter, which would require multiple steps to transform and prepare before generating the final query. Finally, CTEs are excellent for comparing a large number of disparate pieces of information. For example, you may want to create a summary table examining the marketing, sales, growth, and engineering team's performance on their key metrics last quarter. With CTEs, you can extract data about each team's performance, one after another, and combine them into a single query. Okay, let's practice some variations on these techniques to see what your results would look like.
Natulog na naman. Okay. Get team names with the subquery. So let's solve a problem we've encountered a few times in this course. So how do we get both the name, both the home and away team names into one final query result? So out of the four techniques that we've discussed, this can be performed using subqueries, correlated subqueries, and CTEs. So let's practice creating similar result sets using each of these three methods over the next three exercises, starting with subqueries in from. Yes, I just have to. I'm already sleepy. So select main select the match from match as in where wait, I think it's inner join. Create a query that left joins team left join team as T hometown. Grabe, nantok na naman. For the next instruction, add a second subquery to the from statement to get the away team name, changing only the home team ID. Get the home and away team names. So select m.date, get the home and away team names. 1, 2, 3, 4. Just 4 topics and we're through. So I'll just finish this lesson here because I'm already sleepy. Okay. So get team names with correlated subqueries. So let's solve the same problem using correlated subqueries. Then how do we get both the home and away team names into one final query result? So this can easily be performed using correlated subqueries, but how might that impact the performance of our query? Then we have to complete the following steps and to find out. Then please note that our query will run more slowly than the previous exercises. So for the exercises, for the instructions, using a correlated subquery in the select statement, match the team underscore API ID column from team Antok. I just put the hint and just answer. Team PID equals since I'm really sleepy. I'll just run the code. I'll just run the take a hint or show the answer. Then create a second correlated subquery in select yielding the away team's name. The away team's name. Hi, hello, Miss Bell. Hello, good evening. Inaantok. Okay. So, good evening po. Okay po. Thank you po. Ay, thank you so much. Maraming mali. Yielding the away team's homes. Create a second correlated subquery in select yielding the away team's name. Okay. So, let me see the match. Wait. The match table from. Thank you po. Thank you so much. run the code. Ay, salamat. Okay. So how far are we? 87%. So I guess it's wait.
Building on the previous lesson, another important type of subquery
So still have 2, 1, 2, 3, 4. Still 4. Ah, okay. So I've already answered this. Solution. And also this. Okay. Okay. Get team names with CTE. So how far are we? Okay, two more. So get team names with CTEs. Now that we've explored two methods for answering the question, how do we get both the home and away team names into one final query result? So let's explore the final method, which is the common table expressions. I don't like these common table expressions too much. I prefer the correlated nested queries. Okay, so common table expressions are similar to the subquery method for generating results, mainly differing in syntax and the order in which information is processed. So for the instructions, select ID from match and team long name from team. Then join these two tables together in home team ID in match and a team API ID in team. So match ID and long team name from match as M. Oh. Where do I get team long ID? So it's on the team. Team long name from team. Team long name. That left join team. Okay. Select ID from match and team long name from team. Then join these two tables together on home team ID. On home team ID. So wait, let me C again. From match as M. Okay. On home team ID in match and team API ID in team. Wait. Team API ID. Let me run the code. Let's see. I think this is correct. Okay, it's just the first. We have two more instructions to fulfill. Okay, so declare the query from the previous step as a common table expression. Select everything from the CTE into the main query. Then our results will not change at this step. So practice, practice, and practice, and practice with home as. Select from left join from home. Okay. Then run the code. Then on the third instruction, let's declare the second CTE away. Join it to the first CTE on the ID column. Declare the second CTE, then diba? Mahaba pa pala. So, declare and set up the away CTE. But how do I declare it? The away CTE with home as select on comma. Parang kulang ng select them into the main query. Okay. Only the first city is declared using with. Afterward, use the city is name, away, and as. Okay. it's as I've said, it's confusing. So away as, because I thought I have to use again. I thought that every CTE has to be declared as. Okay. So, away as. On. Ah, M that away. Team ID. Oh, but am I doing this right? M.id. Okay. Okay. Let's try. I hope this is correct. So that. Okay. Now we know the three separate ways to manipulate and transform data to produce a complex query result. Yes, it's really complex. This is a great set of skills to have when working with complex relational databases. Ay, salamat. Okay. So, kala ko tapos na. Okay, so we're still not finished. We have still to answer this. Okay, so the previous three exercises demonstrated that in many cases, we can use multiple techniques in SQL to answer the same question. Yes, we have to have alternative ways to alternative ways to gather data or extract data, or in any problem solving scenarios, we have to have alternative ways on how to solve it, so we can check if we gather the same result, just to counter check. Okay, so the previous three exercises demonstrated that in many cases we can use multiple techniques in SQL to answer the same question. Based on what we've learned, which of the following statements is false regarding differences in the use and performance of multiple nested subqueries, correlated subqueries, and common table expressions? Is false. Which is false? So correlated subqueries can allow us to circumvent multiple complex joins. Then common table expressions are declared first, improving query runtime. I think it's true. So correlated subqueries can reduce the length of your query, which improves query runtime. Then, multiple or nested subqueries are processed first before the main query. So I guess the answer is the third one. Why can't yan? So says here that although correlated subqueries can reduce the length of our query, they can also significantly increase query run in time. Okay.
Great job. You now have experience transforming data using simple subqueries, correlated subqueries, and common table expressions. Let's tackle another limitation you've likely encountered in SQL, the fact that you have to group results when using aggregate functions. If you try to retrieve additional information without grouping by every single non-aggregate value, your query will return an error. Thus, you can't compare aggregate values to non-aggregate data. You can work around this limitation using a window function. Window functions are a class of functions that perform calculations on a result set that has been already generated, also referred to as a window. You can use window functions to perform aggregate calculations without having to group your data, just as you did with a subquery in select. You can also use them to calculate information such as running totals, rankings, and moving averages. So what's a window function? How do you use it? Let's start with a query from Chapter 2, where we answered the question, how many goals were scored in each match in 2011, 2012, and how did that compare to the average? This query selects two columns from the match table and then used a subquery in select to pass the overall average along the data set without aggregating the results. The same results can be generated using the clause common to all window functions, the over clause. Instead of writing a subquery, calculate the average of home goal and away goal and follow it with the over clause. This clause tells SQL, pass this aggregate value over the existing result set. The results are identical to the previous statement that used a subquery in select with a simpler syntax and a faster processing time. Another simple type of column you can generate with a window function is a rank. A rank simply creates a column numbering your data set from highest to lowest or lowest to highest based on a column that you specify. Let's take the same query as the previous example without the window function and use it to answer the question, what is the rank of matches based on the number of goals scored? We can answer this using the rank window function. In order to set this up, let's add a new column in select as you see here. To create the rank, you start with the rank function using parentheses followed by the over clause. Inside the over clause, include the order by clause and the column or columns you want to use to generate the rank. By default, the rank function orders the results and ranking from smallest to largest values. In the case of our data set here, this isn't particularly informative. You can easily correct this by adding the descending function to reverse the order of the rank, just as you would if you were using order by at the end of your query. You'll notice that the rank function automatically ties identical values, such as the first two results, and then skips the next value in the rank. There are a few key considerations when using window functions. First, window functions are processed after the entire query except the final order by statement. Thus, the window function uses the result set to calculate information, as opposed to using the database directly. Second, it's important to know that window functions are available in PostgreSQL, Oracle, MySQL, but not in SQLite. Okay, let's practice some simple window functions using the over clause.
Okay. So I guess I'll stop here and discuss this chapter on my next stream, hopefully tomorrow. Wait. Since I've already finished the correlated queries, nested queries, and common table expressions, I'll discuss these on discuss, or rather, I'll take this up on my next stream, and hopefully, I can finish this in a single session or single stream. So, hello, hello. Hello, Christy Pai. Thank you. I'm already sleepy, so I'm ending my stream because I'm really sleepy. And I think I've discussed. Good evening. Actually, my stream is on data analytics. I'm hoping to get a certification, so I can open myself up for better opportunities. So it's just that I'm already sleepy. Good evening. Thank you. Okay, sige. Thank you so much. Wait, I'll just so with this, since the lesson for today is over, I'll discuss the next topic on my next stream. Hopefully I can do it tomorrow evening, same time at 8 o'clock p.m. Okay, thank you everyone. liking the streamer.